everyone, welcome back to another video. Today we will be learning about k nearest neighbors. Okay, so we'll be diving into one of the most intuitive and powerful algorithms into machine learning, which is called k nearest neighbors, or in short form, it is called KNN. And by the end of this video, you'll gain an understanding not only about how KNN works, but when you should use it, when should you optimize it, how can you implement it from scratch. It doesn't matter if you're a complete beginner or if you're trying to solidify your understanding. This video contains everything. So the things which we'll cover today are going to be the intuition, how the algorithm works, the choosing the right k values. We'll implement it in Python as well. Okay, and then we'll say advantages, limitations, etc. Okay, so we'll just jump straight into the video. Uh, Before we go in, I would like to say, if you guys do like these kind of explanation videos about machine learning stuff and all, make sure you do like this video and subscribe so that a lot of these videos would be uh, hopped right into your feed. And yeah, I think let's just start. Surprisingly, KNN is one of the most easiest algorithms that you can understand in whole of machine learning, and it comes under the part of classification. So basically, what classification means is, for the people who don't know, you are trying to classify the given data point into different classes, into different targets. So let's say you have a data which can show different birds. Okay, let's say you have a data which shows different birds. Let's say these are all the features of the birds, like wingspan, or let's say what else, the size of their size, their weight, their complexion, etc. And then at the end you have a indication of what species that bird belongs to. Now, this kind of data where you actually classify the given data points into a certain species is called as a classification algorithm. So basically, KNN is one of classification algorithms, is one classification algorithm. And surprisingly, it's very simpler to learn than many other classification algorithms. So we'll just get into what it is. So imagine you want to go to a restaurant. Okay. Uh, I'm trying to draw a restaurant here. Imagine you're trying to go to a restaurant. What do you think would be your what would be your thought process if you want to go to this? If you want to see whether you like, if how do you want to decide if you like this new restaurant? One thing is, you'll just ask a couple of your friends who have already been there to that restaurant, right? You'll just go to them and be like, hey, did you go to this ABC restaurant? uh, it's a new restaurant, do you think it will be nice? And then people will say, okay, let's say there's like five people you asked five people about this restaurant. One guy says, yes, yes, this restaurant is good. I like it. Another guy says, yes. The third guy says, no, I don't like it. The fourth guy also says, no, I don't like it. And the fifth guy says, yes, I like it. So what will you try to uh, nudge in this direction? Like, majority people did say that they like to go to the restaurant, but a little minority said you don't like the restaurant. So you now are having to make a decision between all of your friends from the data you've collected from all of your friends, and you'll be like, hey, a lot of people are saying yes, so maybe the restaurant is really good, I'll go there. Okay, now this is basically how KNN works. Basically, KNN works on this exact principles, like you are what your neighbors are. Okay, basically you are like your neighbors. In basically in machine learning terms, we predict something which is based on the nearest neighbors. In this case, you will change your decision to go to the restaurant because a lot of people have said yes, they like the restaurant. Okay, now let's like visualize this with some data. Okay, so that it will be much easier for us to understand. uh, Okay, so let's say I have a data like this, data distribution like this. In this data distribution, let's say these kind of points denote some apples in the data. Okay, I'm just taking a random data. You don't have to worry about the access and all. I just want to show you this so that you can get a proper understanding. Okay, and then this data, let's say they represent lemons over here. All right, so we have this kind of distribution of the data right here. Now, what do you think would be, let's say if I've added, now, now that you have this distribution of the data, let's say you have added this point right here. Okay. Now, what would you classify this? Would you classify this as apples or would you classify this as lemons? How would you decide what you can classify this as? Okay. So we'll just take some trivial points. Let's say your point is situated over here. Now, what would you choose for this point to be? You'll choose that, hey, I'll check the neighbors. I'll check the neighbors of this point. Oh, the neighbor of this point is apple. The neighbor of this point is apple. The neighbor of this point is apple. So most neighbors which I've seen, a lot of them are apples. So maybe I can just classify this point as an apple, right? That would be your thought process, correct? But what if I put it over here? What if I put the point over here? What if there's a new point over here? Now, you'll do the same thing again. Yes, you'll check the place where it is situated. Let's say it's situated near a lemon, near a lemon, near a lemon, near an apple here. But as you can see, the nearest apple is very farther away than the nearest lemons, right? So you'll just say, since I have a lot of majority of lemons beside me, I'm probably a lemon as well. Okay. So this basically is how KNN works. Okay. What happens is whenever we select a new data point, we'll check all the neighbors of that data point and make sure that the ones which are near to that data point given in the actual data is a point which will classify it as. Now, this is basically this is KNN in a nutshell, but there is so much depth which we need to take care about it here. Okay, so we'll actually break it down how it works step by step. Now that you know a basic understanding, like if you want to classify any points, you'll see the nearest neighbors of that point and then you will be able to classify it as that particular point. Okay. Now we'll actually see how KNN will work. There's a few steps which you have to understand in order to see how KNN actually works. So basically, KNN stands for K nearest neighbors, right? K nearest neighbors. Now, let's just break down this. What does it mean? So we've already seen about nearest neighbors. If you want to pull out a point, you'll see all the surrounding points which you have to plot against it, and then you'll find the one which is more probable of this point to be. Let's say there's like four apples, and then two lemons beside this point. You'll classify this point as apple. Okay, why do you classify this point as apple? Because majority of my nearest neighbors tend that it's an apple. We've seen this in the same example we've seen here as well. Now, what is your opinion being influenced by? Oops. What is your opinion being influenced by? You're influenced by three yeses and two nos. Since majority of them are yeses, you'll just say that, hey, my opinion is also yes. I think I'll go to this restaurant. Okay, this is the basic idea of KNN. Uh, Now, what does this K value mean? K value just means that whatever the number of comparisons you are having to make, whatever the number of neighbors you are trying to decide before you say that I am this point. So, in this case, the K value is 6, right? Because why? We are choosing six different points. Okay, we are choosing six different points before considering. Now, let's say in this case, what is the K value which we are checking? We are checking K value as 5. Why are we checking K value as 5? Because we are considering 5 people's data. Let's say even if there's a sixth person data, we will only check the nearest 5 people. Okay, let's say let's just take this case of apple right here. We'll just take this example here. Now let's say the K value of -3. Okay. Now, what will be the three nearest points for this point? One would be this, one would be this, and one would be, let's say, this. Okay. I know this is the nearest point, but let's say this is the nearest point. Okay. Let me just highlight it so that you guys can see it properly. Okay. What are the three nearest points? One of them is this, one of them is this, and one of them, let's say, is this. Now, since your K value is 3 for this new point, you'll be able to see that, hey, majority of my k value is red. So is apples. So I'll just classify this point as apples. It's as simple as that. Okay. K nearest neighbors is as simple as that. You can just check your neighbors and see the majority of them, whatever they're doing, and then do it. You've understood what K nearest neighbors mean. Now we'll just see how K nearest neighbors steps work. Okay, we'll see what the steps are, and then later on we'll see different ways to calculate it. Okay, so what have we done? We'll just replicate what we've seen above. So basically, what did we do before choosing the algorithm? It is the first job of the player to choose a value of K. Okay, so K means the number of neighbors to consider. Okay, now this K value is called as a hyperparameter. For the people who don't know what a hyperparameter is a parameter. Sorry, METER. Hyperparameter is a parameter which can be messed around by the developer so that he can tune this value to get accurate results to his data. This is called hyperparameter. This is a very, it's like a knob, a tuning knob for, let's like say a radio station or something. Okay. So we'll tell about how you can choose the right value of k later. But for now, all you need to know that this is the number of neighbors we will consider. So our step one is to choose the value of k. Okay. Now the second point is you already have your data with you, right? This data you already have it with you. The second point is you have to let's say if you are plotting a new point, you are plotting a new point. Okay. What was the step which you've done? You've checked the nearest points of it. K nearest points. Okay? K times. So you've checked the K nearest points of this particular point, and then you've seen that, hey, this one might be this one might be this one might be yellow, this one might be red, let's say. So you've checked the distances between this point and the surrounding points. Okay, what have you done? You have checked the distances between this point, this new point which you want to classify, and the existing data points which you already have. So this would be the second step. Okay, so when a new data point arrives, we'll calculate the distance to every point in the training data set. We should do it for every single one. Okay, this is actually one of KNN's characteristics, which we'll discuss the implications of that later. But this is one of the KNN's characteristics. You have to uh, calculate its distance to every point in the data set. Okay. And then finally, once you've calculated distance, let's say the distances are like this. This is the third step. Once you've calculated all the distances, let's say the distances are like this. Okay. Let's say we're considering like 5 neighbors. Okay. And then distance to point this is this. Okay. And then this is this. And then this is this. Let's say the points distances are like this. 1, 2, 3, 4, 5. These are the different points in my data set. Okay, and no, for the example, let's just take the k value as uh 3. Okay, we'll just take the k value as 3. This is definitely not 3 and 4. We'll just interchange this. Okay, now if you can see, with this is a new point which we want to classify, and then these are the existing points which I already have. Now you have found out the distances between them. Now what do you want to do? You want to sort these distances. Okay, you have to sort these distances. We solve these distances and then we'll select the k smallest distances from this. Okay, these are our k nearest neighbors. Now, what are the k smallest distances we have? We have 1 to red. Okay, okay, and then we have 2 to another red, and then we have 3 for this yellow. Okay, and then we have 4 for the red, the distance of 4. Red is staying at a distance of 4, and then yellow is staying at a distance of 5. So since now that we've sorted all of these distances here, we'll just select the top k. Now since our k value is 3, we'll select the top 3. Okay, we'll select the top 3 values, top 3 distances from here. Okay. By the way, this has to be in ascending order, not in descending order. You have to find which are closest to you, not something which is farther away from you. Okay. Now, what is the next step which you have to do? Now, basically, each neighbor will have to vote for their class. Okay, and the majority class will win. Let's say if uh, there's like 2 votes for this red class. Okay, and then there's one vote for this yellow class, which is lemons. Okay, so now this point will have a majority saying that, hey, I have two red points and I have one yellow point. Now, you can easily decide which one you have to go for in this case. You have to go for the red, saying that, hey, now I can classify this point as red. Okay. So basically, this is how KNN actually works. Okay. In classification problems, you just do this general majority voting stuff. But if you want to use KNN for regression as well, instead of using classes, you might use some other values in here. Okay, then you'll have to consider the average for those values. But KNN for regression is very rarely used. There's a much better algorithms which you can use for regression. But KNN for regression, if you want to use KNN itself for regression, if you have any certain discrete points instead of these classes, you will be able to use that. You'll be able to average the values of all of that and make sure that this new value will get the average of that. Whatever the new point will be there, the new point will be assigned the majority value of this both. Okay. Now we'll just write like a pseudocode of this, of this KNN algorithm, and then so that we can like clearly understand the steps which we will be taking. Pseudocode does nothing. We're not doing any coding. We will just be writing a sample code, which make sure that this KNN value, sorry, this KNN algorithm works in the steps we have described above. Okay, so let me just show you again the steps. We have to select the K value. Okay, and then we have the what do we call it? We'll find the distances to all the K values. After you find the distances to all K values, you will sort the distances in ascending order. Okay, after sorting the distances in ascending order, you'll take the top k values from those ascending order distances and then return the majority class. Okay, so we'll just write this as a code. Okay, so that you'll get a clearer understanding. So I'll create like a function called KNN. Okay, now this is not limited to any programming language. I'm just making this as a code so that you guys can understand this. Now let's what are you given as an input for KNN? Okay, you are given a new point. You're given a new point which you want to classify, and you have to decide the value of k. Why? Because k is a hyperparameter, which is something the developer has to decide. So you'll be given a new point which you have to classify, and then the k value. So let's just take those as the parameters here. Okay, let's just take new point and the value of k. Okay, these are the parameters which I'll be using for KNN. Now, what do I need to do? What is step one? We've chosen the value of k. Now, what is step two? Step 2 is to find the distances of all the points. Okay, so let's just do that. I'll take like a distances array. Okay, I'll take like an array where I can append all the distances. Again, this is not limited to any code. I'm just writing it so that you guys can have a clearer understanding. So for each point in data, in the data which we already have, okay, what we can do, we'll take a distance of that point. Distance is equals to find distance. Let's say there's a function called find distance, which can find the distance between the new point which we have and that point which we are given here. Okay, so let's say we get the distance here, and then we'll just append this to the dist array. Okay, let's just append distance to this dist array. Now we'll have an array containing distances between the current point and every other point in the data set. Okay, we have to do it for every other point, or else we will not be able to find the top k values. Now, after you do this, what is the next step which we have seen? The next step which we have seen is to find the distances between all the points and then sort them. Okay, so we'll just sort this distance array. Okay. Now, finally, the nearest k values uh, of this current point will be the top k of these. So we can just slice the distance array from 0 to k. Okay, that means we'll get the top k values from this distances array. I mean, this is a pseudocode, but you'll be able to check the classes as well. You can write a place where you can like check for classes as well. Maybe you can take a in Python, maybe you can take like a array of tuples where you can do distance comma class, and then sort it based on distances. Okay, you can do that as well. Finally, once you get the nearest k, you'll just take a majority vote of it. So we'll just take a majority vote of it. Majority vote. Let's think there's a function which calculates majority vote of these nearest k values, and then we'll just return it. It's as simple as that. Okay, this algorithm is very straightforward, but the details will make all the difference. Okay, now that we got that out of the way, you guys might have noticed that we are not doing any specific training for KNN in whatever we're trying to do. And that is completely valid because we are not going to train specifically for an algorithm. These kind of algorithm, this KNN algorithm, these kind of algorithms which don't require specific training phases are called lazy learner algorithms. Let's lazy learner algorithms. Now, I'll just tell you what these lazy learner algorithms are. Basically, if you want to know, think of like a lazy learner as a student who doesn't study ahead of time. Okay. Instead, they'll just take all the textbooks, notes, and they'll just keep it all untouched. They won't touch those. And then when the teacher asks questions, they'll like quickly go through the notes and then find the answer. Okay. Now, basically, I'm trying to relate it in such a way that uh, a lazy learner is someone who will wait until a question is asked before doing the work. But eager learner, the opposite of lazy learner, is someone who studies in advance. He builds a summary or formula of the whole question and then quickly answers when the question is asked. Okay, so the one biggest example for lazy learners algorithm is KNN algorithm. Okay, like during the training phase, you don't need to build any formula. You don't need to do. You just need to store the list of features. That's it. Okay, you just need to store that data like we did here. We just stored whatever apples or lemons which we had. We didn't have any data which we wanted to we didn't build any summarizing model, or we didn't build any particular formula ahead. Okay, all the things which we are trying to do is during the prediction phase. What are we trying to do when someone gives you a new fruit, whenever someone gives you uh, a new data point? We are trying to see all the stored fruits which and find which of them are most similar, and then in the closest fruits, if let's say the closest fruits are apple, you'll say this is an apple. So there's no work which you're doing during the testing phase, training phase. Sorry, you're doing no work during the training phase. So, like one more key example: if you go to a party and ask anyone like who here likes a pizza, a lazy learner would just walk around the room, answer everyone, and then answer. But an eager learner would already make a chart of people's food preferences before the party, so that uh, he can answer it easily. Okay, so the key takeaway is lazy learners will not prepare anything in advance. They just store the data and only wake up to work when they are asked a question. Okay, but this makes them simple to use. Usually it is slower to implement because we are considering all the data points which we need. We're not doing it immediately, and then whenever we are trying to do a testing, we are having to come across all the kinds of all the data. Okay, so this is basically KNN is basically one example of a lazy learner algorithm. I hope that is clear. Now, there's a few things which we have to see before we have to understand KNN completely, and that is one of them is the distance matrix. Now, what are these distance metrics? Distance metrics basically mean here in KNN, we are trying to find the distance between, oops, right here in KNN, we are trying to find the distance between the given point and the actual point, right? The point in the data and this. So, your algorithm depends on how we are calculating this distance as well. Okay, there's several ways in which you can calculate this distance. A simpler way is plot them in a graph like this. Okay, let's say the given point is x1 comma y1. Okay, the point which you are trying to predict, the newer point, is x2 comma y2. Okay, simple distance formula would this be the square root of x2 minus x1 whole square plus y2 minus y1 whole square. It's a simple distance formula, which I think a lot of you people might remember this from your geometry class. It's just the straight line distance between 2 points. Okay. Now this distance is called as a Euclidean distance. Euclidean distance. Okay. This formula is basically called a Euclidean distance. It's literally Pythagoras theorem. If you guys are familiar with Pythagoras theorem, it's basically Pythagoras theorem. You just calculate a right angle right here, and then you find the value of the hypotenuse. Okay, that is basically how Pythagoras theorem works. Now this is called as a Euclidean distance. Now there's one more way in which you can calculate this distance, and that is called as Manhattan distance. Okay, that is called as Manhattan distance. Now, what is this Manhattan distance? Manhattan distance is named after the street grid in Manhattan. Okay, basically, if you have ever been to Manhattan, or if not, I'll just tell you. The houses in Manhattan are arranged in the form of blocks like this. Okay. So if you want to find the exact distance from, let's say, this point in the road to this point in the road, you can't just be a Spider-Man and just jump over these houses, right? You'll have to walk across the blocks like this. You'll have to walk across the blocks like this in order to reach this point. Okay. So that is what Manhattan distance is. Manhattan distance covers the block dimensions as well. Basically, the formula of this would be, let's say this is x1, y1, this is x2, y2. Then the minimum distance which you can cover is this plus this, right? So that would be x2 minus x1 in the mod plus y2 minus y1. Okay. This is called as a Manhattan distance. Okay. It basically has this grid layout kind of thing. There's some other distances which you can follow. They're called Minkowski distance or cosine similarity. You can do cosine similarity, or you can do Hamming distance between 2 points. So any of these you can use, but mainly you will use this Euclidean distance for numeric data. Okay, like if you have any continuous numeric data, you will be using Euclidean distance. But if you have more discrete data or data in higher dimensions or anything, you will use Manhattan distance. Now, one factor which we have seen is the distance matrix, right? Now, the next factor which we have to see is about choosing the value of k. Now, choosing the value of k is as important as doing the whole algorithm itself, because if you have a certain proper value of k, you will be able to represent your data properly. Okay. Now, there's some few unspoken kind of rules which you have to follow while choosing the value of k. There's some unspoken rules which you have to follow while choosing the value of k. Basically, k is a hyperparameter, and then choosing it currently will make sure that it can represent your data properly. Okay, so we'll see what happens with different k values, and we'll see how it will change for everyone. Okay, now let's say you choose a very generic value for k, which is 1. That means you're just looking at one neighbor. Okay, one nearest neighbor. What happens? This will create like a very complex decision boundaries. If you have 2 to 3 points of different kinds, okay, let me just show that in different colors so that you guys can see it properly. You have different points like this. This is your data representation. And then if you have a point over here, a new point over here, now, this effectively would not represent. Now, if you just consider the k value as 1, this would effectively not represent the actual data properly. Okay, you'll look at the first neighbor which is very nearer to this, and then you'll be like, hey, this is an apple. Let's say in this kind of data itself, you have let's say in this kind of data itself, you have for a new point, an apple is situated at 1 at a distance of 1 from the this thing, and a lemon is situated at a distance 1.01. Okay, both of these are almost similar to this to this one. Okay, and so in this case, when you choose k value as 1, you will say that, hey, this is an apple, but you will be also seeing that lemon is also a valid response which you can choose. So basically, what k equals to 1 tries to do is it will memorize the training data perfectly. Okay, if you try, it will try to see which is very close, and then it will keep adapting to the closeness itself. Okay, and uh, whenever you try to do new data or new kind of predictions, or if there is any outliers or any noise, it will fail. Okay, one. Okay, so basically, if you have at least one misrepresented point, at least one outlier, let's say there's one outlier, apple here. Okay, and then there's a new point over here which is very close to the apple than to the lemon, but that point is actually a lemon. But apple, which is an outlier, is closer to that point. Then your model will incorrectly predict that this is also an apple. Okay, if you choose k value as 1. But if you choose k value as something greater than 1 or something which is not 1, then you will be able to see that, hey, I have other values which are lemons. Only this one is apple. So I'll go with lemons, which is the majority voting. Okay. Now we'll go to the other extreme. Well, let's say you like have let's say you have like 200 data points. Okay, okay, and then you're choosing 100 as the value of k. K is equals to 100. Now what will this do? Okay, so for each prediction, you're trying to check 100 different other predictions. Like you're basically doing half of the other predictions. Okay, then what happens is the decision boundary will almost become like a straight line. You'll not be able to, you're trying to divide this into a certain path. That's it. You're not trying to find the nearest neighbor. You're just trying to divide the data into two halves. That's it. Either you'll go on to this or you'll go on to that. So in this case, model will become too simple. If the model becomes too simple, that is called as underfitting. Will lose the ability to capture the subtle patterns in the data. Okay. Now you're saying you can't go to the very low, we can't go to the very extreme. How do we do it? We have to find like a sweet spot. Okay. Now, usually how people do it is they'll try finding out different values of k. Okay. And then they'll find, let's say, uh, for different values of k, they'll try to find the error. Okay. The curve would be something like a U-shaped curve. Okay. Initially, this would be the error. Okay, so basically, as the value of k increases, you'll see that, hey, at one point, the value of k, the at one k value, my error is actually very low. So this might be my correct k value. This is how people usually do. They'll usually iterate from k is equals to 1 to some n, and then they'll be able to see, hey, at this point, my k value is very low, so I'll just be doing this. Sorry, my error value is very low, so I'll just be choosing this k value. All right, so now that we've understood how KNN works, I think it is a better exercise for us to understand and type and write how KNN actually works from scratch so that we can have a practical understanding and then we'll be able to code it up as well. So I'll be using NumPy for this. So let's just import NumPy as NP. We'll be using NumPy and object-oriented programming in Python. If you guys don't know about object-oriented programming, I highly recommend you guys look at that as well. But as we go, if you, I'll cover a few concepts as well. So we'll just create a class of KNN. Okay, and then we'll create a constructor. Okay, in this constructor, what do we have to do? We'll just have to take the value of k from the user. Okay. Now we can add a toggle which can make the user select either a Euclidean distance or Manhattan distance. We'll do that later on. Okay. But for now, we just need to initialize a k nearest neighbors object so that we'll need to so that we can just give a class. Now we'll just define variables inside this. So we'll just take the value of k. Okay. We'll just create dummy variables for the training and testing data set as well. Okay, so we'll just take the train values. We won't need for the testing values because we can just invoke the stuff from the testing values. Okay, now after this is done, let's just write a method. Let's just write a few methods which are useful. So I think one helper method which we would like is to find the distance. Okay, so we'll just declare a function. We'll just call it Euclidean distance. Euclidean distance. Now, what does this Euclidean distance will take? It will take the 2 points. Okay, and then it will return the distance between these 2 points. Okay, so uh, we'll just take square root of the sum of x1 minus x2 whole square. Okay, basically this corresponds to the formula. If x1 and x2 are 2 points having, let's say, two values each, then you'll just subtract those two values and square it, and then you'll do a sum for those. Next, now that we've seen the distance, the next thing which we have to do is to just fit the model. So if you have worked on sklearn, you would have known what fit means. Fit basically adds the it just basically trains the model. But in this case, since we have no training, we'll just initialize our training and training variables in our KNN. So we'll write a function called fit. Okay, what will it take? It will take the values of x and y. Okay, and then it will just assign them. So self dot x train is equals to x, self dot y train is equals to y. Okay, this will just initialize them. We don't need to do anything else in fit, because why KNN is a lazy learner algorithm. KNN is not an eager learner algorithm. So we don't need to do anything while training. We will just do everything while prediction. Finally, now it's time to predict the values. Okay, so we'll just define a function called predict. Okay, what will it do? It will take the value of x. It will take the value of all the features, and it has to give us a target. Okay, so we'll just write like a helper function over here. Okay, so we'll just write like a helper function here. We'll call it predict single. Okay, now the job of this is to do all the things which we are trying to do for of the each data point in x. So if the x has 100 data points, we'll run predict single for 100 times. Okay, so we'll just what will predict single take? It will also take the value of x. Okay, but since it's a smaller data point, we'll just rename it as small x. uh, why is this showing an error? Okay, we'll just write pass here so that this function implementation will be written later. But what is the first thing which we have to do? We have to find the distances. We've seen in the class, so we'll just take a distances array, and then using list comprehension, we can just write self dot Euclidean distance of x comma x train. Basically, what we are trying to do is we are trying to find the distance between x and x train for each x train in self dot x train. What are we trying to do here is we are trying to write it in the form of list comprehension that, hey, find the Euclidean distance between x and x train for every value in the given training data set which we have. Okay, now now that we have all the distances covered, we can what we can do is we can sort these distances. So we can get the top k indices by doing the by sorting them. So we can do arc sort. Okay, now basically what arc sort does is it will basically sort the array and return the indices that would sort the array. So we can just take distances here. Okay, now this will give us the different values in which we can the different indices from which the shortest distances will be present. Now you can just slice this from 0 to whatever the k value is. Okay, so that we can get only the top k values. Okay, again arc sort will just sort this whole array and return the indices of the sorted array. Okay, it will not sort the distances manually, it will just give us the indices of the sorted thing. Okay, now that this is done, what we have to do is we have to extract the labels. We have to extract the different labels of these x values. Okay, we only have the point for training here, but we need to have a point for testing also. So the testing points will be extracting from these training points. How? We'll just say k nearest labels. Let's call it k nearest labels. And then what we can do, we can just do self dot y train of I for I in k indices. Okay, what this will do is for every point in this k indices, it will just extract the value of the y train from there. Okay, and finally, the most common will be, let's say we'll take a counter, we'll create a counter for these k nearest labels, and then from this we'll use a method called most common, and then at the 1. Okay, okay, and then we can just return this most common from here. Okay. Now since we've used counter, we have to import that as well. So you can just import it as from collections import counter. Okay, and then just run it. So now that we've seen how we can predict for a single value, we can use the same to predict for different values as well. Okay, how do we do that? We can just write it as predictions is equals to self dot predict single of I for I in X. Okay, this is how we will do for every single thing. Okay, and then we'll just return the predictions. Okay, or we can just return it in the form of a numpy array. That would be much better. Okay, so this is basically KNN algorithm. Whatever we've seen here, this is how KNN algorithm works. We'll just take like a sample data, iris data set, and then we'll see how this will perform on that. Okay, so let's just import the iris data set from sklearn.datasets. You can import load iris. Okay, and we'll do a train test split as well. So you have to split the given data into training and testing. So we'll do from sklearn dot model selection import train test split. Okay. And then we have to see the accuracy as well. So from sklearn dot metrics import accuracy score. Okay. And this is from not from. We'll import accuracy score. Okay. Now we'll just load the iris data set. Okay. So it's just as simple as calling this function. Okay, and then this function we can just take the values of training and testing by just doing iris.data and iris.target. This will make sure that these x and y values have the data and the target values in them, and you can split this data x train, x test, y train, y test is equals to, you can do the train test split, which we've seen earlier. You'll give the value of x comma y, and then test size you'll be taking it as 0.2. That means only 20% of my data will be used for testing, 80% will be used for training. And then you can do random state is equals to 42, so that you can replicate this behavior in any code you can in any code you extract. Now let's just define the KNN class, okay, which we've made here on top. And then let's say the value of k is equals to 3. Okay, we decide to give the value of k as 3. Okay, it's just as simple as just calling knn.fit. We'll be able to fit the values of x train and y train. Okay, and then finally to make the predictions, we can do predictions is equals to knn.predict for x test. Then we'll get the values of y pred, okay, y predictions. And then finally we can measure the accuracies as accuracy score of y test and predictions. Okay, and then we can just print this. So let's print this and see accuracy. Let's just multiply it by 100. Okay, and we'll just round it off to two floating point values, and let's just see what happens. So what is the error? Random state. This is random state, and we got an accuracy of 100%. Basically, the error was we had to convert the values into numpy array, and then we had to extract the topmost answer properly. We were not doing that, and once we've done that and we've run this, as you can see, we got a accuracy score of 100% on the test data in iris. So that means our KNN model is working perfectly, and we are able to classify each problem properly. Okay, now here we have a way in which we can use other metrics. So in the above code, we've just seen how you can use Euclidean distance. But if you want to use Manhattan distance as well, you can have that toggled as well. So I'm just taking another parameter called metric over here. And then if the metric is Euclidean, then return this. If the metric is Manhattan, then return this. Otherwise, you just raise an error saying that, hey, this I don't know what this metric means. Remaining all the code is as it is, the same. Okay, so you can just specify the metric in which you want to calculate, and then you'll be able to do it. Now, there's a library, sklearn. You guys might have seen this. We have used this library here. Sklearn also provides KNN KNN support, so we can just import from sklearn.neighbors. We can import k neighbors classifier. This is this is what is used for KNN, and then we can just name it KNN sklearn. Let's say we can name it KNN sklearn is equals to k neighbors classifier, and then the number of neighbors is 3. Okay, so we'll just say KNN sklearn dot fit xtrain and then ytrain. Okay, it's the same. The pipeline here is the same. Predictions is KNN sklearn dot predict x test. Okay, and then accuracy, we'll just copy paste this here. Okay, and then we got the same thing. So you can, instead of writing KNN from scratch on your own, you can use sklearn as well in order to do that. Now that we have a basic understanding of how KNN works, we have seen the implementation of KNN in Python. We've seen how KNN works. We'll just see some real world applications where KNN is used. One major place you can see where KNN is used is in recommendation systems. Okay, so basically, if you have anything like YouTube, Spotify, Netflix, anything, if you like enjoyed, let's say, 3 movies, then KNN finds users with similar taste profiles, and then it will recommend you what they liked. Okay, so this is also called as collaborative filtering. KNN basically is used in this case as well, and you can use KNN in image classification as well. During image classification, okay, so given pixel values as features, the KNN will be able to identify and classify these images. And like while this is not as powerful as CNNs or deep learning networks, it is still used for like quick prototypes or when you have limited data. It still be useful. You can use KNN for anomaly detections as well in cybersecurity. So anomaly detection. So basically, you can use like it can detect like unusual patterns, or it can flag data points that don't have many nearest neighbors, etc. Or you can use it for handwriting recognition, MNIST, etc., etc. So these are some kind of applications which are applicable for KNN algorithm. And coming to advantages, there's a lot of advantages for using this KNN algorithm. The first thing is, let's just go to this tab over here. Advantages. The basic advantage is it's very simple to use. The KNN algorithm is the most simplest algorithm to use, and there is no training phase in KNN algorithm. Okay, KNN is a lazy learner, like we've seen. It just stores the data and it will wait until there's a proper prediction time, and basically there's no need to perform any specific. There is no need to write any specific techniques. It will naturally handle multi-class problems. Naturally handles multi-class problems. You don't have to do anything for it to handle that, and it is easy to just add new data. It is easy to add new data to KNN, and it works well with small data set, smaller data sets. If you have smaller data sets and you have to do a quick classification algorithm, you can use KNN. Okay. Now, there's some limitations to this as well, which are the disadvantages. What are they? What are they? It is very expensive during prediction time because we were having to check all the data points. Expensive during prediction because we were having to check all the data points during prediction time, and it doesn't scale well to higher dimensions. So since we are using a distance metric, Basically this is called curse of dimensionality. That means in a very high dimensional space, you all these points will become roughly like equidistant, and then KNN will lose its effectiveness beyond like 10 to 20 features without any feature reduction. So if you have higher dimensions or higher a number of features, it will lose its effectiveness very easily. Doesn't work well on higher dimensions. Okay, and then one more quick thing is it is very sensitive to irrelevant or noise. Okay, we've seen that as well. That example as well. If there's like one apple and then five lemons, but the apple is much closer than the other lemons, and if you're taking the k value as one, it is saying that the point is an apple. So it is getting influenced by noise. So we can just say it is easily influenced by noise. Okay. And yeah, I think that's pretty much all the disadvantages which you can have. And let's to quickly summarize, we'll see what we've covered till now. Basically, we've seen what KNN is. KNN will predict based on the majority vote of the K nearest neighbors, and you can choose based on whatever distance metric you wanted to use. You can either use a Manhattan distance or you can use Euclidean distance. And it is always better if you use proper validation to check k values and optimize the values of k. We have seen that as well, how you can choose different values of k. And yeah, you also seen how you can implement the values of k, and you've also seen how you can see the you can also you've also seen the advantages, disadvantages of KNN. And if you want to practice some great data sets out there, MNIST data set, Iris data set, wine quality, Boston housing data sets, all of these you'll be able to see. So yeah, I think that's pretty much going to wrap up on how on KNN this thing. So I hope you guys have understood, at least gotten a clear understanding how KNN works. So yeah, if you found this video helpful, please do like and subscribe and drop a comment if you have any questions, or if you want me to cover any other algorithms or in depth, or if you want to give me any suggestions. And yeah, that's pretty much it. Thanks for watching.